We're now going to look at linear sequences example 2. So it gives us a linear sequence, minus 3, minus 7, minus 11 and minus 15. Remember, the reason it's linear is because in this case it's going down by the same amount each time. You're subtracting 4 every single time. So when a sequence goes up or down by the same amount each time, it's linear. So part A, it says find the nth term formula. Remember, the nth term formula is a formula that connects each term number n to its corresponding term value un. So in the sequence, these are term values. So we start off by copying out the sequence, and then beside those we write term values un, u with a little subscript n. And then above the term values, we're going to write down the term numbers. And the term number for short is n. So minus 3 is the first term, minus 7 is the second, minus 11 is the third, minus 15 is the fourth term. Now, the nth term formula always starts with un. So the first thing we write down on our page is un equals. And now we have to work out what the common difference is. So the common difference is what we're doing each time. Okay, so in other words, we're subtracting 4 every single time to get from one term value to the next. So minus 4 is our common difference. Now the common difference tells us what the coefficient of n is going to be in our formula. So straight away we can write un equals minus 4n. Now we have to test to see, does this nth term formula work? Does it map every term number n to its term value? Let's start by chucking in n as 1. So when we throw in n as 1, we're expecting the term value to be minus 3. So chuck in n as 1, we get minus 4 times 1 is minus 4, but we want our answer to be minus 3. So what have we got to do to minus 4 to turn it into minus 3? We're going to have to add on 1. So that's the bit that we modify. Now check that it works. When we sub in n as 1 here, we get minus 4 times 1 is minus 4, and then add on 1, we get minus 3. It works. Does it work when we chuck in n as 2? Minus 4 times 2 is minus 8, plus 1 gives you minus 7, so it works. And it works for 3 as well. Minus 4 times 3 is minus 12, add on 1 gives you minus 11. Chuck in 4, minus 4 times 4 is minus 16, plus 1 is minus 15. So we've now found our nth term formula. So that's part A. Now, part B says, why is minus 25 not a term value in this sequence? So what we're saying here is that if we keep subtracting 4, you'll find that you'll never get a term value of minus 25. But how can we prove it? Well, you can actually prove it by subbing the term value of minus 25 into your nth term formula. So replace the term value, un, with minus 25 and solve for n. What you'll find is that n will not be a whole number. In other words, the term number that has a value of minus 25 won't be a whole number. Now the problem is term numbers can only be whole numbers. You can't have a 1.5 term, you can't have a 3 1/3 term, you can't have a 4 1/2 term. All term numbers have to be whole numbers. So we're going to sub in the term value of minus 25 and solve to get its term number. And then what we'll discover is the term number will be a fraction, and that proves that minus 25 is not a term value. So in part B, we're going to sub in the term value of minus 25. So replace un, remember un is your term value, so we get minus 25 equals minus 4n plus 1. Going to move the minus 4n over to make it positive, so we get 4n. And then we're going to move minus 25 to the other side and change its sign, so we're going to have 1 plus 25. So we're going to have 4n equals 26, and then we're going to divide both sides by the coefficient of n. So 4n over 4, and that's equal to 26 over 4. 4's cancel over here, so we're left with n, and then 2 goes into both, so we're going to be left with 13 and then 2, and 13 over 2 is going to give us 6.5. Now, that's what we said. The reason minus 25 isn't a term value is because when you work out its term number, it's not a whole number. So that's why you know it doesn't lie in the sequence. So since the term number is not a whole number, because term numbers have to be whole number. So since the term number is not a whole number, then minus 25 can't be a term in this sequence. Okay, let's look at part C. So part C says, what term number has a term value of minus 31? So we're going to do the same thing. We're going to go to our nth term formula and we're going to sub in a term value of minus 31, and we're going to work out what term number it is, and hopefully this time it will be a whole number. So part C, sub in term value of minus 31. So go to your nth term formula, replace the term value with minus 31, and then that's going to be equal to minus 4n plus 1. Again, move your minus 4n over to make it positive. Move minus 31 over to change its sign, so we've got 1 plus 31. So we're going to get 4n is equal to 32, and then divide both sides by the coefficient of n. So 4n over 4, and that's equal to 32 all over 4. 4's cancel, so we're just left with n, and then 4 goes into itself once, goes into 32 8 times, so 8 over 1 is just 8. So this time the term number is a whole number, which means that minus 31 is a term value in the sequence. So we've worked out that the term value of minus 31 corresponds to a term number of 8. In other words, the 8th term has a value of minus 31. So final answer is n equals 8.